this, Juliana actually mentioned that we can look at both of these tables, and we know that it's increasing, right? But a table isn't good enough in order to visualize. So what's a good thing that we could be using to visualize this growth? What could we use to visualize this growth? A graph. Let's move to page 3. Like I did it on purpose. All right, so off to the sides, we are going to use the table of values that we came up with before in order to plot the values. I want you to go until year 10. So we're going to go pretty far into it. So let's start off with a table of values for the simple interest. Please do this off to the side. So for simple, let's create an X and Y grid. And as I mentioned, we want to go until year 10. So we're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9,
Is it simple or is it compound? Which one was the biggest? Okay. And the final thing we're going to figure out on this page is the percentage increase.
All right, and now for these 4 years, we already have those values. All right, so let's just plug those in.
How do we figure out the percentage growth for the second one?
We have 1,000, 1080,
No.
1160,
I like your thinking, but that's not how much.
1240,
So we're comparing.
and
the 4
1320.
years. So what do we have to do over
All
here?
right, so those are from the previous page. All right, we already have
So
those.
we're gonna take, what is okay. 1,013.60.
All right, so how are we going to fill in the rest of this table if we only have the first 5 values?
What do I end up with?
What do we have to do, Marcella?
You have 36 because you used previously, and they plug in the X values are left.
Excellent.
Okay.
Is there an easier way to do
So
it?
based on our model of.
I agree though, we could use the equation, right, and plug in 5, and then plug in 6, and then plug in 7. What's a shortcut? Wafa?
We know that we're increasing by 80, so we just keep adding 80.
Excellent, yeah, we know that we're increasing by 80, so you can just add 80
This gives us 36.
over and over again. Alrighty? So, with your study team, fill in the rest of this table and graph the points, alright? And then connect the points, alright? Let's give you guys about 4 minutes to do that in your study teams. Finish the table, graph the
So the
points.
first one,
Go
we're
for
at
it.
32% in 4 years. The exponential model, oh my, you with us? The exponential model grew by 36%.
Alright, so finish the table and then plot the points.
Cool. Okay, let's go ahead and. Okay. The graph is a little complicated.
What's
with
the
the
next question?
numbers, so we're actually going to flip ahead. If we have time and we finish these questions, we'll then go back to the graph. Okay, so we're going to flip ahead to that last page.
Feel free, make sure you're using your calculator for this. You don't have to do this all in your head.
Oh, we'll find out. Okay. So go ahead and read 733 and attempt A, and then we'll review our answers. Okay, very similar to what we just did.
One is over here. Yeah, it's spread out by a few. But sorry about that.
Just like we did before.
I'm done. Nice. Awesome. So we're going to start plotting the points. So can you start plotting the points, Jose? Starting with 1,000. It's a really big grid, I know. Inappropriate.
Good stuff.
Wait, where is it? 1,080 is a little bit over 1,050. So just approximate. I know, I was like, you're going to 18,000? Nice. And at the very end, what should this look like?
What number are we going to find?
What is that called? A linear increasing, exactly, an increasing linear line. Good job, guys. Make sure you connect the points.
And then add strikes.
I need a visual.
Okay, Adam, tell us what you got for the equation.
Yes, please, because then in the end, if we did go past 10 years, we went to 20 years, it'll keep going up, right?
Yeah.
If you finish simple interest early, feel free to start on compound. Compound is a lot more confusing though.
With our legs, okay, good. We were able to identify that this is an exponential growth, and what clue does it, what in the question told us this was going to be exponential? And that's,
This is like the animal, this is like it grows like a growing.
yeah, so we've got an 8% annual interest, okay? It also does say that we've got compounded quarterly, okay? That's what's going to make this question complicated. This one is compounded quarterly, which means 4 times a year your interest gets compounded, okay?
Maybe this is like trying to figure out financial aid.
Okay, so for B, we're going to use our model to find the value of your 1,000 investments after 4 years.
Looks like some people have started with the
So
compound
first thing,
interest.
go ahead and try to set up the equation for that. So we're looking at this equation after 4 years.
Where does it say that?
This one's off, because these should be forming a straight line.
After 4 years.
Right, check your numbers again.
I ain't ready.
You can evaluate on your own.
You okay, you go.
That's number 4.
Yeah, but you copied it wrong because you can't see, so you need to evaluate it on your own. Juliana, evaluate it on your own.
Yeah, but don't say like that. Just sit there like and
Juliana, go sit down and evaluate it on your own. Thank you.
No, he could say it, but you see how he like say it like
It's my mom.
Okay, alright.
Oh, she's the one.
Okay. Somebody tell me what you changed about this equation. What did you change from there to there?
I substituted 4 years as an exponent.
Okay. Is this what we all did? Okay. This is what happens in 1 year. Okay, this interest is compounded quarterly. That means 4 times a year, this is happening. Okay, if we want this for 4 years, what do I need to do? What do you think?
16.
16, yes. It's like 4 times 4. So then we've got y is equal to 1.
Feel free to start working on compound interest. I'm just writing the first 4 points. Those are from the previous page, all right?
Okay. So we've got 4 years, and it's 4
So now we gotta so now we gotta do that one.
Yeah, so we're doing this one to find out how much we would make at the end of 4 years.
Alrighty, MG group. How would we evaluate at year 5? Because year 5 is not provided for a compound interest
So I
situation.
think that most of us did like.
How do we evaluate for year
Because
5?
it happens 4 times per year, we need 16 amounts of interest.
I got 3,225. So,
Yeah, Melissa, can you just mention what you said before?
yo.
That is correct.
Exactly, yes. Let's do it on our calculator together just to really remember how to do this.
125.
Alright, so we would plug in 1,000 parentheses, 1.08 parentheses. How do we get that little number on the top?
You write the,
Yeah, Jose, what is it?
Technically that is in dollars.
How do you get the little number on the top?
You had it.
you see the carrot above.
And
the-
then we're asked, how does this compare
Yes,
to other
exactly.
investment options? So from the 2 that we did over here,
Enter, you got your.
how does this one
Most
compare?
excellent. So we put in the 5 there. And at year 5,
one's more
we
simpler,
earned
the other one's more
$1,469.32
No, I
cents.
think it's compared to like accounts.
How would we evaluate for year 6?
Yeah, cause like you have to like do like exponential.
Melissa?
And then you basically have to do like the same stuff.
Excellent, yeah, so just plug in,
So
do
it's
this again, but
most
now instead of 5, you're gonna plug in 6.
And then which
Alright?
one gave us the most in the end after 4 years? So we had,
The compound.
was it this compound or this
Oh,
compound?
just like 30.
This one, okay. Adam, tell us, what was the amount that we made with compound interest on this page?
Alright, MG group, because we're running out of time, I'm gonna give you all of these points. I just want you to graph them,
The compound.
okay?
Compound, yeah.
Awesome, so let me just give you the points. At year 6, 1586.87. 1713.82,
1320, okay.
1850.93.
What is the difference here?
1999.00,
Which one
And
would you want if you were investing
21.58.
money? This one, okay, we won quarterly compound interest, okay? It makes us a lot
Alright,
more
so
money
these
in
are-
exactly the same time. It's like 3 times as much, but in exactly the same
the
time.
final 6 points that you need, or the final 4 points.
Great, let's have a look at the last question. Great, this is actually kind of what we talked
The
about.
same thing, I
So
got you.
go ahead and substitute it
I'm
in.
not done.
We're using our models from this page. Okay, Danelle's actually already ran one of these for us.
Nice, Mariana.
You already did one of these for us. So when you take these models.
Hopefully you start to notice that it's not a linear function anymore.
These two?
It kind of curves up a little bit at the
To
end.
change 20 here.
So
So
grabbing
that is, that's one of the.
Can I copy these and?
Absolutely, yeah. Okay, so we're checking what would happen in 20 years.
You tripping, bro?
Nice.
You tripping.
So remember you? There's 1,000.
Okay, great. Label that one compound. And then find out what would happen with the simple one. And how much money would you have with the simple model?
About 2 more minutes with graphing compound interest, and then we're gonna move on.
So this model that we made, you can substitute it in 20 years to that and figure out how much it
So I can, I'll take out the 1,000
is. 1,000 is the same as the investment.
Oh,
Then
yeah.
next is the years.
Oh, I'm grabbing. Yo,
So education. I don't know, I thought we did the same thing, oh, you did 16 as well.
So yeah, we did
So we
16
should
years.
connect the ones, and now it just looks like a scatter plot, right? But we definitely have
Yep, you
functions
got
going
it.
on.
So that's our compound, and then we're also gonna find out what will happen in our simple equation.
Oh, the end is a little off, but the end is over 2,000, so it's like, should be somewhere like up
So
here.
wouldn't 20 go in here?
Exactly, you got it.
All right, about 40 more seconds to work on compound interest, and we're gonna be moving on. Wonderful.
You got it, Ellen? Okay, great. So after 20 years, which one has the most? Is it compound or is it simple?
Compound.
Okay. And how long would it take us to make the same amount of money with simple interest? How do we think we're gonna find that out?
30 years.
Remember, with compound interest, it has a little tail at the end. This is an exponential function.
So, we just found out that for compound interest,
Yeah, you did the
is
same
equal
thing, that's so
to
funny.
4, 6,
Marcella did it right
6,
though.
Nope.
point
It's
nine
like
six.
35.
Okay.
Nice.
You
You
just
just
an easier way
label
than guessing. Trial and error is an okay method, but it's gonna take you a while, okay? So we know that y is equal to this. What can I do with that y? Where can I put it?
What, like,
Where do you plug it in?
45.
45, you're really close. Okay, so I'm gonna substitute it into our other equation, our simple equation, okay? What's our general formula for this simple interest?
Alrighty, MG group. We're gonna move on from the graphing.
it was 8 of
This is what it should have looked like. Jose's group, can I get you guys eyes a beer, please?
45, 25.
So this is what it should have looked like. Alright, notice the simple interest is a linear function. It just grows by 80 every year. Every year goes up by 80. The
Trial and error
compound
telling us
interest,
45.5.
it
We're
starts,
gonna
Lily,
solve
at the
for it,
same
okay?
place
How do I solve for x in this equation?
as the simple, but notice that over the years, it starts to go away from that. It starts to grow and grow a lot more than our simple interest, alright? Simple has a constant rate of change,
Okay, what's
and
my
this one has an
Divide by 80,
exponential
divide by 80.
growth, alright? Any questions about these?
45.8.
No? Excellent. Can I get you guys to turn to page 4, please? Move away from the graphing. Oh, I almost showed you the point.
45.75, which would approximate to be
Alrighty.
46 years.
We're gonna have 4 minutes to work on
Wow,
problem
very close.
733.
Yes.
This one's a little bit different. Now it's compounded quarterly. So that means that it happens 4 times per year. Discuss with your team, how does that change
Okay.
our
So
equation?
simple
Does it
interest
change it
will
at
take
all?
a much longer
733,
time to get
4
to
minutes,
that
go
much.
for it.
Okay, are we happy with that? Okay, cool. We only have a couple of minutes left. 46 years is a long time, okay? You can go ahead and try this, okay, with plotting the equation. So take your models, are you with me? Okay, take your model, that's simple, find out what it is. You can start with the numbers that they gave us here. We're plotting these numbers onto the graph. Let's create the line graph, okay? So remember, our first one should be a linear equation.
Not necessarily, so if it was one quarter,
Start
like
with
four.
those points. If we got some more time,
So that would
add
be
some
times
more
four.
values. Okay, we're plotting the data onto our graph.
Miss, by 2079 and 46 years
Or
ago,
X is just-
61.
Yeah,
So if you
yes,
invested
it's
right
four
now,
and then it's
for
half.
a long time to reap those benefits.
Right, so in 2079,
The compounded.
I wonder how long it would take.
Wait,
I wonder how long it would take me if I reached
Because
100.
again, whenever you invest, you expect to get more money.
Won't be 100, right? 21,008.
So this is our general equation, so that means you have to have an X somewhere.
I'm gonna be
It's like
invested.
we don't know why, we don't know X, we haven't plugged it in.
So if you're gonna invest, based on what we've done today, would you use a compound account or a
Oh my god.
We don't, exactly, we don't know
compound
that.
account? Yeah, so you want that one that's giving you more interest.
Now.
So I'm gonna be rich by the time I die.
Let's say that 4 years.
Potentially, yeah, if you did a good
Just plug in
investment
four.
and it's compound, you'd probably be less rich if you did simplify. Happy with that? Okay, so go ahead and start plotting these on this graph. I can see it.
So it compounds quarterly, so how many
These values
times
onto the graph.
do you add more money every year? 4, and how many years are we talking about? So how many total times does it happen? 16. It compounds 16 times over 4 years. So then what's gonna be our exponent? Right, so that's why I was mentioning it was kind of complicated, right? Nice. Good job,
This is
Jose.
what I got.
Alright, what are we thinking?
Getting more money.
I mean,
Yes, so it's gonna be a plus situation, so let's start creating the equation. Y equals what?
That's good, okay. So now keep going. We can keep adding on. So remember how we can add it? So if you added 18 to this for the year.
But now what changes? It's compounded quarterly.
Yeah.
It does it 4 times, right? Do we need to include that 4? Say yes, no? Yes? Do we know how many years have passed though? No, so we're just gonna leave it as X. We're gonna leave it as X. And now, on the next problem, how many years have passed? 4. So are we gonna plug in 4 for X? Because again, it compounds quarterly, so if it compounds 4 times in a year, no, and 4 years have passed, so how many times has it compounded so far? Right? 16. 4 times in 1 year, and then 4 years, so that's 4 times 4, it compounded 16 times. Yeah, so that becomes our exponent. Good job, guys. Nice, looks good. So now, how do we evaluate for part B? Part B is the
That's
technical
good.
part.
Okay, and then schedule items.
Yeah, why is it 4 times 4?
4 years past. I messed up right there.
It's okay.
And then every 4 years,
Now you're also gonna plot your exponent.
it compounds quarterly, right? So that means every 4 months, you've added your investment. And then it's asking you, how many years have passed? 4. So what's 4 times 4?
Lord. I
16.
did something wrong.
Yeah.
Where do these two values come from?
Alrighty, about 2 more
One
minutes to finish
is for-
7:33. If you have finished it, start moving on to 7:34.
Just on the other, the compound.
Compound, okay.
Checked it.
So the general idea is to combine.
Yes, I see.
So one of them is linear, and then what did you say that the compound one was?
Exponential.
Exponential, okay, so one of our graphs should look like this, it should be linear, one of them is gonna look like that, yeah. So we're gonna need to figure out some more values to be able to see where it's merged. So what you can do,
More work for me.
what you can do
Sucks.
is find the values. Okay, we already did this one together.
Alright guys, final minute,
1360.
What did we get for how much money we would earn after 4 years?
We got that one up on the table.
Does that make sense? That we originally started with 1,000 and then it grew up to 3,000? Yeah, right, because if it compounds quarterly, you're getting money every single quarter, right? So more opportunities for money, yay money.
1 year 5. Okay, you can either do it with the method that we did where we like multiply and then add, or you can simply divide into the formula that we're doing.
Oh, this one isn't involved. This one is. So this one would just be 20 years. Yeah. So for the, it's asking when,
5 years.
so you figured it out for compound, right? So that's that. It's asking if you wanted to earn this amount from your simple interest, what equation is that? Exactly, so you have to find y equals mx plus b. Alrighty, you guys, everyone, including Rued Group, we're gonna transition back into shoulder partners, please. Let go.
Happy with that? Let me not steal That's okay.
Miss Word was
Say that again, Denise.
those are chairs.
Oh, that's okay.
Omar. Adam, I'm gonna just put my desk up. Alrighty, you guys, as you're packing up, totally fine to continue packing. Awesome job, Denise. We're gonna be reviewing tomorrow, alright? This is where everyone should be paying attention. You guys do not do well when we're at the end of the period and working together. The last time that we had to meet during 6th period, 4 people were referred. Let's not have that happen tomorrow. That means come ready to learn, come ready to review. Alright? I will not see you Thursday. The exam is on Friday. Awesome work today, you're free to go. If you didn't get the homework, let me know. Yeah, you can do that.
What's